Let's look at solving excuse me, these exponential inequalities. So these are the same problems except one it's greater than and one it's less than. So you solve it like normal. In fact, this is like the last problem in part one. Okay. Here was the problem where without logs, you have this. And so solving it gave us negative 0.9950. If it had been a greater than, it would have come out as x is greater than negative 0.990, except for the fact that because of this being a negative number and we divided at some point, it's possible that it should have switched. We don't know if it should have switched. What we're going to do is to find out what happens, which numbers is it greater than or less than numbers that will make this correct. So let's pick a number one way or the other and see if it's true. The easiest one here is to see that for 0, if I put 0 in, it would be either greater than or less than. 0 is a greater than number, greater than that negative. So let's see whether or not it truly is going to fit this one. So will 0 as greater than that make this true? Well, 7, 2 times 0 is 0. That means that's a 1. Is that greater than? Well, if I put 0 here, 52 to the third power, no, it is not. It is not greater than. That means that the correct answer would be the less than number, negative 0.9950. That would make this one true. The other side now we know numbers that will make it true to be less than that, not greater than that. So before I picked 1, well, let's see if I did the same thing now. If I'm using 1 now, I'm going to get that 2 or 0. I'm saying that x is 0 for that. If I say that x is 0, I get 0. 7 to the 0 is a 1. And is that less than? Well, if I put 0 here, that becomes 0, so it becomes just a 3. 52 to the third power. I don't need to know what that is to know that 1 is less than that. That means that that's a true statement. Okay, so that means that numbers that are greater than will make this true. So here, this was true. Here it was false because it had to be make one side greater than the other. Here it had to make one side less than the other. And because a 0, x equals 0 worked, that means now this one is true in this case. Greater than. Let's see, it was less than. Yep, it's greater than this one because 1 is greater than the negative 0.9950. Negative 0.990. And if we did 2 or 3 or 4 or 5, we would find the same thing to be true, that it would make the left side less than the right side. So we end up with a switch of signs. We have to test it. So the key idea here is to test an x, test a value. Okay, here's a couple others to do. This one now, these are the same problems except one is greater than one is less than. But we haven't solved this one before, so we're first going to have to solve it. So that means I'm going to do log of both sides. So we're going to get 5x log 12 greater than 3x plus 1 log 7. I'm going to multiply log 7 to both of these things. 3x log 7 plus log 7. Now I'm going to move the two terms that have x's in it to the same side, meaning I'll subtract to this one here. 7 minus 3x log 7. So I now have a 5x log 12 minus 3x log 7 greater than log 7. Let's take an x out. 5 log 12 minus 3 log 7 greater than log 7. And we'll just simply divide by this whole thing so that we're saying x is greater than log 7 over 5 7. Nope, it's 5 log 12 minus 3 log 7, because that's what this is here and here. When we put that into the calculator, we get that x is greater than about 0.2954. So we're going to check, and I'm going to use the number 1, because that's an easy one to use in a problem. So if I put 1 here, okay, and the reason is because 1 is greater than 0.2954. So if I put 1 into this original, it becomes 12 to the 5th power greater than, and in parentheses, is it really greater than? The other one's a 7. So 1 times 3 is 3, plus 1 is 4. 7 to the 4th power. That's about 248,832, and that is indeed greater than 2,401. True. So x is greater than 0.2954. Now we're going to do it as with this less than. So in this case, if I solved it the same exact way, I would have gotten that x is less than 0.295. So let's check it and see, is it true? Will it make this a true statement if you take a number that's less than that? So let's use x equals 0. 12 to the 5 times 0. Is it actually less than 7 to the 3 times 0 plus 1? Well, 5 is 0, 0. 12 is 0 is 1. 1 less than 0 is 1. 7 to the first power. 1 is indeed less than 7 first power. That's true. Therefore, this is correct. Whoops. Okay, so now that part is correct here. So what you've seen is you solve it as if it was an equal, go through the whole thing, keep the sign there, and then check to see if it was so. If this had come out here on this one as false, I would have reversed the sign here. I would have reversed that sign, and I would have realized that at some point in the work, I had divided by a negative, but because I didn't know that the x was negative, I didn't know that yet, and there was no way to know, only by checking at the end. And in this case, it looks like all the correct x's are positive, so it couldn't have been a negative, but you always check to be sure in this kind of a problem. Well, I hope that helps with these especially. Thanks for watching and listening.